High above our heads, stretching for hundreds of kilometers, lies one of the most vital and yet invisible protectors of life on our planet, the atmosphere. This delicate, multi-layered blanket of gases wraps around Earth, acting as a shield that is absolutely essential for our survival. It's not just a passive covering. The atmosphere actively controls our climate, moderates temperatures, and keeps our planet habitable by maintaining the delicate balance needed for life to thrive. The atmosphere protects us from the sun's harmful radiation, filtering out dangerous ultraviolet rays that could otherwise make life impossible. It also acts as a barrier against meteors, causing most to burn up before they ever reach the ground. Thanks to this shield, we can enjoy sunny days, breathe clean air, and witness natural wonders like the aurora borealis. Today, we'll embark on a journey to explore the atmosphere layer by layer. We'll uncover how each layer works, what makes them unique, and how they interact to create the weather and climate patterns we experience every day. But our atmosphere is changing, and it's happening faster than ever before. From pollution and greenhouse gases to global warming and extreme weather, we'll see why understanding our atmosphere is more important now than at any point in human history. The atmosphere is a mixture of gases wrapped around Earth. It's made of nitrogen, oxygen, carbon dioxide, water vapor, and tiny particles. This blanket of air keeps our planet warm, allows weather to form, and filters dangerous rays from the sun. Our planet is wrapped in a protective blanket of gases called the atmosphere, which is divided into 5 distinct layers, each with its own unique characteristics and vital roles. Let's take a journey from the ground all the way to the edge of space, exploring each layer and discovering what makes them so important for life on Earth. The lowest layer, closest to the ground, is called the troposphere. This is the layer we live in, and it stretches from the Earth's surface up to about 8 to 15 kilometers high, depending on where you are on the planet. All the weather we experience, clouds drifting by, rain pouring down, snowflakes falling, gusty winds, and even powerful thunderstorms, happens right here in the troposphere. It's a dynamic, ever-changing region, constantly mixing and churning as warm air rises and cool air sinks, creating the weather patterns that shape our daily lives. The air in the troposphere is thickest and most dense, which is why we can breathe easily at ground level. As you climb higher, like when hiking up a tall mountain, you might notice the air feels thinner and it becomes harder to breathe. That's because the amount of oxygen and other gases decreases with altitude. The temperature in the troposphere also drops as you go higher. On average, it gets colder by about 6.5 degrees Celsius for every kilometer you ascend. This is why mountaintops are often covered in snow, even when it's warm at the base. Above the troposphere lies the stratosphere, which extends from the top of the troposphere up to about 50 kilometers above the Earth's surface. The stratosphere is much calmer than the troposphere below, with very little mixing of air. This is the layer where commercial airplanes often fly, cruising above the turbulence of the weather below for a smoother ride. But the stratosphere is famous for something even more important. It's home to the ozone layer. The ozone layer is a thin, invisible shield of gas that absorbs most of the sun's harmful ultraviolet, UV, radiation. Without this protective barrier, the sun's intense rays would be deadly to plants, animals, and humans. The ozone acts like a natural sunscreen for the entire planet, allowing just the right amount of sunlight to reach the surface, while blocking the dangerous UV rays that can cause skin cancer and damage living tissues. Thanks to the ozone layer, life on Earth can thrive. Plants can grow, animals can roam, and people can enjoy the outdoors without being exposed to lethal levels of radiation. The stratosphere's stability and the presence of the ozone layer make it a crucial part of our planet's life support system. Next up is the mesosphere, which stretches from about 50 to 85 kilometers above the Earth. This layer is much colder than the stratosphere, with temperatures dropping to as low as -90 degrees Celsius. The mesosphere is where spectacular natural fireworks occur. When meteors, or shooting stars, enter the Earth's atmosphere, they burn up in this layer due to friction with the air. The bright streaks you see in the night sky are actually tiny bits of space rock being incinerated before they can reach the ground. The mesosphere acts as Earth's natural defense system, protecting us from countless pieces of space debris that would otherwise crash into the surface. Most meteors never make it past this layer, as the intense heat generated by their high-speed entry causes them to disintegrate and vaporize, keeping our planet safe from harm. Above the mesosphere is the thermosphere, a region that begins around 85 kilometers up and extends to about 600 kilometers above the Earth. Unlike the layers below, the temperature in the thermosphere rises dramatically with altitude, reaching up to 2,500 degrees Celsius or more. However, it wouldn't feel hot to us, because the air is so thin that there are very few molecules to transfer heat. This layer is where the edge of space begins, and it's filled with fascinating phenomena. One of the most beautiful sights in the thermosphere is the aurora, also known as the northern and southern lights. These glowing, colorful displays are caused when charged particles from the sun collide with gas molecules in the upper atmosphere, creating shimmering curtains of green, pink, and purple light that dance across the polar skies. The thermosphere is also where radio signals can bounce off the ionized gases, allowing long-distance communication around the globe. The International Space Station, or ISS, orbits within the thermosphere, circling the Earth at an altitude of about 400 kilometers. Astronauts aboard the ISS experience microgravity and witness breathtaking views of our planet, all while traveling at speeds of over 28,000 kilometers per hour. The thermosphere is a frontier for scientific research and human exploration. Finally, we reach the exosphere, the outermost layer of the atmosphere. This layer starts around 600 kilometers above the Earth and gradually fades into the vacuum of space. There is no clear boundary where the atmosphere ends and space begins. But in the exosphere, air becomes extremely thin. So thin that individual molecules can travel hundreds of kilometers without colliding with one another. The exosphere is like a vast, invisible bridge between our planet and the rest of the universe. Here, the few remaining gas molecules drift off into space, and the pull of Earth's gravity becomes weaker and weaker. This is the realm where satellites orbit, far above the weather and turbulence of the lower layers, silently circling the globe and enabling technologies like GPS, weather forecasting, and global communications. Satellites in the exosphere play a crucial role in our modern world, helping us navigate, communicate, and observe our planet from afar. From the dense, life-filled troposphere to the wispy edge of the exosphere, each layer of the atmosphere is essential, working together to protect and sustain life on Earth. The next time you look up at the sky, remember the incredible journey through these 5 layers that makes our world possible. In the upper layers of the atmosphere flow powerful winds called jet streams. These high-speed air currents move weather systems around the world. Your flight time also depends on them. Pilots use jet streams to travel faster. The greenhouse effect is, honestly, a natural process. Sunlight enters the atmosphere, warms the Earth, and then, well, some heat is trapped by gases like carbon dioxide and methane. This trapped warmth, actually keeps Earth comfortable for life. But too much greenhouse gas creates, too much heat. This leads to global warming, rising temperatures, melting glaciers, stronger storms, and unpredictable weather. Human activities like burning fossil fuels increase these gases rapidly. The atmosphere shields us from radiation, burns meteors, controls weather, stores oxygen, and maintains temperature. Without it, Earth would be, well, silent, frozen, and lifeless. So the next time you look up at the sky, whether it's a clear blue afternoon, a starry night, or a dramatic sunset, take a moment to really appreciate what you're seeing. It's not just empty space above you. It's a vast, dynamic world that's constantly at work, protecting and nurturing life on Earth. Just remember, you're looking at a powerful, layered system made up of invisible gases, swirling winds, and ever-changing clouds. Each layer of the atmosphere has its own unique role, from shielding us from harmful radiation to creating the weather patterns we experience every day. It's a complex shield that makes life possible, and it's always in motion, even when we can't see it. This incredible system keeps you alive every second, providing the air you breathe, the rain that nourishes our planet, and the protection that allows life to thrive. Every breath you take is a reminder of how connected we are to the atmosphere above us. If you enjoyed this breakdown and learned something new about the amazing world above our heads, we'd love to hear your thoughts. Let us know in the comments what surprised you most or what you'd like to explore next. And don't forget to like, share, and subscribe for more deep science explained simply. Your support helps us bring more fascinating topics to life, making science accessible and fun for everyone. Thanks for watching, and keep looking up.